Hi everyone, welcome back to my AI-powered mapping series. Today we're going to be building an interesting app using TensorFlow.js. The goal of this is going to be simple. We're going to be filtering a feature layer based on natural language queries. So let's get started. All right, so we've got our basic HTML, CSS, and JavaScript setup as usual. In the HTML, we'll add the TensorFlow link through CDN. Then we'll create a container for the querying. Inside, we'll have a label, input, and button to process our querying. Now, in the CSS, I'll give the container a bit of styling. Okay, now onto the JavaScript. We're first going to define some global variables outside of our map logic for the map view, map, and schools layer, so TensorFlow can access it. Now, inside the map logic, we're going to add our schools layer URL and add it to our map. Now, back outside and below the map logic, we're going to add some training data. This is key to using a simple neural network model with TensorFlow. I've added some queries here, but the more you have, the better the model will be trained. So for the model itself, we're going to be using a simple architecture with a couple dense layers. We're going to start by creating a model using TensorFlow.js. So I'm initializing a sequential model. Next, I'm going to add the first layer. And this is a dense layer, which means every neuron in this layer is connected to every neuron in the previous layer. So we define this to have 32 units, and the input shape is going to be 1, which means the input to this layer is just one number at a time. We're also going to apply the ReLU activation function, which helps the model decide which neurons to activate based on the input. Now next, we're going to create a second dense layer with 16 neurons. The activation function is the same as the previous, and we don't need to specify the input shape because it's already defined in the previous layer. Now this layer helps the model learn more complex patterns from the data. Now finally, we're going to add the output layer. And this is a single neuron with a sigmoid activation function, which is perfect for binary classification. Okay, now that our model architecture is set up, we're going to need to compile it. I'm going to use the Atom optimizer, which is commonly used for training neural networks. For the loss function, we're going to use binary cross entropy, which is appropriate for binary classification problems. And lastly, we're going to track accuracy as a metric to evaluate the model's performance. Now let's look at the function, pre-process data. This function is going to prepare our training data, and we're going to start by extracting the numbers from the queries. So for example, if the query is show schools with more than 1,000 students, we want to extract 1,000. So we'll do this using a regular expression, which looks for digits in the string. We then create the labels for the training data, and each label represents whether the query is asking for more than or less than. If the query asks for more, we'll return 1, and for less, we'll return 0. Now we prepare the input and label data by converting them into tensors using tf-tensor2d. Next, I'm training the model with the fit function. We're going to pass in our input and label tensors, and we're going to tell the model to run for 500 times. Now the batch size is going to be 4, which means the model will update its weights after processing 4 data points at a time. Next, let's go ahead and process user queries. When the user enters a query, we're going to convert it to lowercase so we can easily compare it. Then we're going to extract the number from the query using our regular expression. And once we have the number, we create an input tensor from it. And we're going to use the trained model to make a prediction. If the prediction is above 0.5, we're going to consider this query as asking for more than, and otherwise we're going to say it's less than. However, we also are going to want to handle a few different ways that the query might be phrased, especially since we're using a small training data set. So for example, if the query contains words like at least, more than, or over, we're going to interpret this as a higher number of students. Conversely, if the query contains less than, under, or below, we're going to filter for fewer students. And now that we have the appropriate SQL query, we're going to pass it to the apply layer filter function, and this will update the feature layer's definition expression which filters the data shown on the map. And then finally at the bottom, I'm going to make sure to start training my model to start the whole process. All right, let's go ahead and test this out. After my app loads and my model has been trained, which takes a few seconds, I'm going to test out a query. Let's try the example that's given. So show schools with more than 1,000 students. I type this in, click filter, and we can see all the schools that have more than 1,000 students. And that's it. Today we were able to build a natural language filtering system for our map using TensorFlow.js. It was a simple app, but it can be expanded with more training data and better models. Thanks for watching, and happy coding!